Okay, so first topic on today is going to be finishing the NAT on the iOS, which is going to be the policy NAT configuration. So we've spoken about what NAT is, just about the configuration steps of policy NAT. So we have we're gonna be able to configure either policy dynamic and static NAT or policy dynamic and static path. While let's say from the what policy NAT means point of view is going to be the same thing, from the configuration point of view, it is going to be a difference. So first of all, as usual, we define what is our inside NAT and outside NAT interfaces. Second of all, we define what traffic to be translated, and here's the difference. If you want to do a policy static or dynamic NAT, you have to use an extended ACL and call that ACL in a route map. That's for a specific reason, because in dynamic NAT and static NAT, the iOS and any NAT device builds a one-to-one mapping. And I'm going to of course show it up on the configuration, but if you want policy NAT, which means a source is going to be NATed differently based on the destination, it means that we don't want that one-to-one mapping to be done, because if it is, then I cannot NAT the same source into multiple in different ways. So I'm going to explain it when we go to the configuration side, but to keep it simple, if you do policy static or dynamic NAT, you have to match on the traffic to be translated by an extended ACL and call that ACL in a route map. If you do static or dynamic policy path, then an extended ACL is going to be enough. Now, of course, when we did NAT the other days, yesterday with static NAT or dynamic NAT or even path without policy, we used a standard ACL that was good enough. So with policy NAT, you have to use extended ACLs, because policy NAT means I'm going to NAT the source differently based on the destination of the traffic. So it makes sense that you have to use an extended ACL. While in regular static NAT or dynamic NAT, using a standard ACL is good enough because you just match on the source. So it makes sense again. Then, like in any kind of configuration, you optionally define an IP pool for translated addresses. This is only for path. For path in one of the other interfaces, this is not required. Or if you do static NAT, likewise, there's no need for that. Then you also put that in there. So now we know that the pool was required. The IP pool was required only in dynamic NAT. So clearly, this step is not required if we do static policy NAT, or if we do path, dynamic path in one of the router's interfaces. So clearly, to keep it simple, the pool is only required if you want to do dynamic policy NAT, which means a one-to-one mapping dynamically done. And then you configure a regular the policy dynamic NAT or path rules based on what you want to achieve. Verification-wise, going to be the same steps. So you verify the NAT interfaces and the NAT type with striping NAT statistics, and verify the translation table to make sure that NAT happened the proper way, like that the source got translated into what you wanted it to get translated by striping NAT translations. Okay, now let's go to the configuration side. So for the moment, initially, we're going to consider that this is not branch A. Let's say this is customer 1, so company 1, and this is company 2. So it's 2 enterprises in there. And what they have is this tunnel 12 in here, this tunnel 12. It is an SVTI tunnel, which means an IPsec tunnel between router 1 and router 2, which is pre-configured. And I'm running OSPF over that SVTI. in order to advertise through that tunnel VLAN 11 and VLAN 91. So it's two companies that they have an IPsec tunnel with SVTI based over the internet, and they share some routing information back and forward to get connectivity to those two subnets. So what we're going to be doing is we're going to go likewise again on router 1. And what we want is that as VLAN 11 traffic goes out on the internet, we want VLAN 11, let's do policy path. We want VLAN 11 traffic to be translated into the interface of router 1. So overload into the interface of router 1 facing the internet. While if VLAN 11 traffic is being sent via the SVTI tunnel to the remote component destination, I would want NAT to happen. Likewise, I'm going to do policy path. I would want NAT to happen into the SVTI's tunnel IP address. Likewise, overload. So based on the destination being accessed, I want to do NAT differently. Which what this means is that configuration-wise, gig 0 is going to be my IP NAT inside interface, and gig 01 facing the internet, and the tunnel interface facing the remote customer, the remote enterprise. Those are going to be my outside NAT interfaces. Of course, I could do something else as well, but this makes much more sense from a, let's say, real-world implementation point of view. Because of course, otherwise I could choose to also do, so in this case, traffic it goes out on different interfaces. But likewise, I could choose to do this to be the inside NAT interface, and this to be the outside NAT interface. And then as traffic goes from VLAN 11, if traffic goes this way, so inside outside to the internet, and if traffic has a source of VLAN 11, destination of router 3 loopback 0, I could choose to NAT that source, that VLAN 11, into an IP of X via path. Or, and also to do policy NAT if traffic is sourced from, likewise, VLAN 11, but is destined to, let's say, router 3 loopback 1, so not a destination. I could choose to NAT that source into another address of Y, likewise doing path. So the reason I said this is that I don't want you to understand that policy NAT works only if the egress interface is different. So policy NAT has nothing to do with the egress interface. So as I said it in the overview part, policy NAT is very simple in the NAT overview part. You're going to NAT the source differently based on the destination being accessed. It doesn't matter on which interface the packet gets routed out to. That's what I said that we can also, this is a valid also example configuration wise, but implementation wise, we're going to do the other one because it makes much more sense to NAT VLAN 11 as it goes out on the internet to do path into the IP address of router 1's gig 01 interface, and as traffic goes from VLAN 11 out to the SVTI tunnel to the other destination, to do path into the SVTI tunnel interface. This makes much more sense from a real-world implementation point of view. And I want to make sure, I forgot to state before we go to the configuration part, to make sure everybody understood something very clearly, which I think I forgot to mention yesterday. For NAT to work, traffic has to flow inside outside or outside inside. Like if I configure this interface to be IP NAT inside and the tunnel interface to be IP NAT inside likewise, then even if traffic flowing between those two interfaces matches a NAT configuration, NAT is never going to happen because it flows between the same type of NAT interfaces. Which is not a confirmation, as I stated yesterday, that NAT was designed to, as traffic went from the inside from the LAN to the outside to the internet, to perform NAT. So if traffic flows inside or outside, no NAT happens. Even if it matches a NAT config, it's not going to happen. Okay, so we're going to do it step by step. First, I'm going to configure this interface to be IP NAT inside, clearly, because that's the LAN part. Then the WAN part, both the internet interface, gig01, and the tunnel interface, which is facing the remote let's say enterprise. Both of them are going to be IP NAT outside interfaces. And then, as I stated, based on the traffic being, based on the destination of the traffic, I'm going to NAT the traffic. If it goes out on the internet, I'm going to NAT it into gig01 interface address via path. If the traffic goes on the tunnel, I'm going to NAT it into the tunnel's interface as path. And because this is policy path, not policy NAT, an extended ACL is good enough to make this config work. So let's go on the configuration side. So router 1 has, from yesterday configuration, show IP NAT statistics, has the inside NAT configured interface, which is gig00, and the internet interface to be outside NAT. The next thing to do is to make the tunnel interface IP NAT outside. So just to confirm that the SVTI tunnel is up and running, because it's SVTI, if it's in the state of up, it means that the IPsec tunnel has been built successfully. But let's confirm that. Show crypto ISAC AMP SA. It is active QM idle. Show crypto IPsec SA. We have one inbound SA to be active and one outbound SA to be active. Likewise, the IGP should work. Show IP or SPF 200 neighbors. So over the tunnel, I have a neighbor of router 2, and I should receive via SPF 200 the other side's prefix. Try router SPF 200. I receive on router 1 the information about the subnet, and on router 2 I should learn via SPF the information about VLAN 11 over the SVTI tunnel. Let's confirm that. Router 2, show IP router SPF 200. And I learn about the remote side prefix. Okay, so let's go on router 1. Make the SVTI tunnel to be IP NAT outside. Then let's see what kind of NAT do I have pre-configured left over from yesterday's configuration. So I have to remove this. That uses a standard ACL. This ACL is standard, is not going to work with policy NAT. Note that. Yes, I want to kill the entries, the translations, and note this. Do show run section IP NAT. I should have no more NAT statements configured. So now let's configure two ACLs. One matching traffic from VLAN 11 to VLAN 91. It's going to be one ACL. And one matching traffic from VLAN 11 to the internet, to any. It's going to be the second ACL. So let's go and configure that. Match on the traffic. IP access extended. Let's say SVTI. Let's call this ACL NAT over SVTI. It's going to be permit IP from 10.10.11.0 to 172.16.10 the remote side dot 0, 0, 0, 0, 255. Exit. IP access list extended ACL NAT for the internet access. Now, and it says this is a more complex discussion based on how you configure NAT, and it's not a long discussion, which is not a scope of the CCNP exam. It could work both if I say permit IP from 10 to any, which means to the internet. But if your configuration, depending on how you configure things back and forward, it may not work because technically speaking, this matches on all destination. I'm going to configure it to work like this as well. But ideally, just to be on the safe side, if you're not sure exactly how NAT is being built behind the scenes, then in this ACL, you should add a new entry, which the first entry in the ACL should be deny that traffic, to make sure that traffic going out to that destination doesn't match this ACL. So as I stated, if you do the configuration properly, it's going to work in this setup as well. As I said, I don't have time to explain exactly why, but just to be on the safe side, ideally in a production network, if you don't really master NAT, what happens behind the scenes, in this ACL you should add one more entry which states deny that traffic to make sure that the NAT configuration which is going to make use of this ACL is not going to match on traffic distant to the other company. Exit. Let me make sure I can make that happen with this. So I'm gonna say ACL NAT. Actually, in this case, is not gonna work based on my config. Well, it should work. Let's say so. Now I configured the traffic to be matched. Now let's do NAT for the internet. Let's do path for internet traffic. I'm gonna do path as I stated into the IP address of gig01. For SVTI, I'm going to do path into the IP address of the tunnel. So let's do the following. IP NAT inside source list. This. Interface tunnel 12 overload. And IP NAT inside source list. This. Interface gig01 overload. Show run section IP NAT. So, and there we go, the problem. Let me do this. No, this. No, this. Let me put it back. Do show run section IP NAT. So because what happens is, as you can see, regardless of the order that I've configured the NAT statements, the NAT statements are ordered alphabetically. So up to including here, everything is a perfect. Let me use red. Up to here, or blue, it is a those two statements are identical. And then the router has put at the first line the line of internet before the line of SVTI, because alphabetically speaking, I is before SVT is before S. So that's why the internet one is going to come up first, which means in this use case, all traffic is going to get netted to this interface out both the SVTI tunnel and the internet. Let's confirm that. So my policy NAT is not going to work. Let's verify the NAT configuration. Show IP NAT statistics. So we see in there our NAT configuration. So now let's try and go initially this way from PCA to SVTI tunnel and to reach VLAN 91. So I'm going to send the telnet traffic from PCA to router 2 on that IP address of 172.16.10 something. Let's make sure router 2 allows Telnet traffic to begin with. Router 2. Line VTI. Telnet traffic is allowed. Authentication list, I'm using with TACACS. Let's make sure if I telnet to myself from here, I'm going to use the CISCO user from TACACS and it's going to work. CISCO. Well, I'm using local authentication because I killed the TACACS configuration. So I need to use the local username of router2 user and router2 user. There we go. I know the TACACS failed because again I see a capital U, which if you don't change that configuration around by default, capital U means local authentication, small u means remote authentication. Either way. Now let's go on PCA and try and telnet to router 2. Telnet 172.16.10.2. Telnet. Router 2 user, router 2 user. If we say who, as you can see, I got NATed with the wrong IP address. And of course, in the real design, this would not even work. In my case, it works because it's a closed environment and I don't have really the internet in there. I got NATed into the IP address of router 1's gig 00, not into the IP address of router 1's tunnel SVTI address. To confirm that, so router 1, because the tunnel address is something in the format of 1212 something. There we go. So the reason again that this happened is because the iOS orders the entries of the same type, of the same NAT type, alphabetically. And this ACL, we know that it matches on all destinations. So that's why it doesn't matter where I go out to, I'm going to be NATed always based on this. In the interface of gig 01, although traffic-wise, I was routed out on the tunnel. So show IP NAT translations. Show IP NAT translations. There you go. I got NATed as expected PCA into the IP address of gig 01. So as I said, I have two options for this. If of course you want to know the internals of NAT on the iOS, either make sure that this entry shows up first, which means change the ACL name, or go in this ACL. That's what I said. I need it to be on the safe side because you never know who comes on the router and doesn't know how it works. Go in that ACL and include one more line, IP access extended, which says line number 1, deny traffic from 1010, deny IP 10.10.11.0 to the remote company protected subnet. Now I want to make sure that traffic flowing between VLAN 11 and a remote company subnet is not going to get NATed by this configuration.